The moment the wheels touch down, something has just happened that most passengers never think about. 300 tons of aircraft, 260 kilometers per hour. All of it absorbed in less than 2 seconds. Not by the runway, not by luck. By a system that was designed, built, tested, and certified to do exactly that. Every single time. I am a licensed aircraft maintenance engineer. I work on commercial aircraft, and landing gear is one of the most underestimated systems on any aircraft. Today I am going to show you how it actually works. Most people think of landing gear as wheels. It is not. Landing gear is a complete load management system. It absorbs energy, controls deceleration, steers the aircraft on the ground, and carries the structural loads of every takeoff and every landing. On a typical commercial aircraft, you have 3 gear assemblies, the nose gear at the front, and 2 main gear bogies under the wings or the fuselage. Each bogie carries multiple wheels. The bigger the aircraft, the more wheels. More wheels means more contact area. More contact area means the load is distributed across a wider surface. That is by design. Every gear assembly has the same core components: a shock absorber, a retraction actuator, a locking mechanism, and a brake assembly on each main wheel. Each one of those components has a job. If any one of them fails, the aircraft does not land normally. The shock absorber is an oleo strut. It is not a spring. It is a hydraulic and pneumatic device. Oil inside the strut absorbs the energy of landing. Nitrogen above the oil acts as the spring. When the aircraft touches down, the strut compresses. The oil is forced through a controlled orifice and the energy is dissipated as heat. Without that process, the full force of landing goes straight into the aircraft structure. The passenger feels a bump. The engineer calls that nominal. 300 tons, 2 seconds, controlled. Landing gear does not operate by gravity alone. It is driven by the hydraulic system. Dedicated actuators. Pressures between 2,000 and 3,000 psi. And it operates in 2 very different states. In flight, the gear is retracted and locked inside the aircraft. Hidden, carrying no load. When the gear is lowered, everything changes. A mechanical up latch releases, the actuator extends. A down latch locks the assembly in the fully down position. That lock is what the green light in the cockpit confirms. In flight, the gear is hidden. On landing, it becomes the only thing between the aircraft and the ground. Green means down. Green means locked. No green light, the aircraft does not land. If the hydraulics fail, well, you still have to land. There is no scenario where the aircraft waits for the system to recover, and the aviation does not accept a single point of failure on a safety-critical system. Every commercial aircraft has an alternative extension system. On most types, this is a gravity free fall. The hydraulic pressure is released from the retraction side. Gravity pulls the gear down. The down latch engages mechanically. No hydraulics required. On some aircraft, there is also a manual crank or a pneumatic backup. The method varies by type. The requirement does not. The gear comes down. In 2005, a JetBlue Airbus A320 departed Burbank with a nose gear fault. During retraction, the nose gear had rotated 90 degrees and would not align for landing. The crew knew exactly what was coming. They had one chance to get it right. They flew circuits for 3 hours, burned fuel down to minimum, then landed at Los Angeles. The nose gear touched down sideways, the tires shredded against the runway. The crew held the nose off as long as aerodynamically possible to reduce the load on the damaged assembly. The aircraft stopped. All 146 people on board walked away. The investigation led directly to revised maintenance procedures for nose gear retraction pin inspections. That incident changed how engineers inspect that component. Now, let me tell you what we look at on the ground. During every walk-around, the landing gear gets a visual inspection, but that is only the start. We check the oleo strut extension. There is a published serviceable range. Too compressed means the nitrogen charge has been lost. Too extended means the strut is unserviceable. We check for hydraulic fluid weeping from the actuator seals. We check the brake wear indicators. Each brake unit has a pin that recedes as the brake wears. When that pin is flush with the housing, the brake is at minimum. The aircraft does not fly again until it is changed. Every time a landing gear component is touched during maintenance, the work is recorded in the technical log. A licensed engineer signs it off. That signature confirms the system is airworthy. Without it, the aircraft does not move. You have probably never thought about the landing gear from the moment you boarded to the moment the wheels touched down. That is exactly how it should be. Because if you are thinking about the landing gear, something has gone wrong. Landing gear is not a simple mechanical device. It is a load-bearing, hydraulically operated, redundancy-designed system with no tolerance for failure. Every component is inspected. Every function is tested. Every extension and retraction is logged. The reason you do not think about it is because the engineers already did. Landing gear absorbs the energy of landing. It operates under hydraulic power. It locks positively in both positions. It has a backup extension system independent of hydraulics, and every component is inspected, measured, and signed off before the aircraft flies. The tolerance on a landing gear system is zero. Not low. Zero. The brakes must work. The strut must be serviceable. The latch must engage. The green light must illuminate. Every single requirement must be met before the aircraft is released to service. Regulation requires it. Physics demands it. I have inspected landing gear on aircraft about to carry 300 people on a 9-hour flight. You check everything, you measure everything, you sign everything, because there is no margin here. When those wheels come down on final approach, it has to work. First time. It has to work. First time. If you want to understand what's actually happening every time you fly, subscribe. See you in the next one.